Okay, so let's take a look at another example. Suppose you invest $5,000 into an account that pays 7.6% interest compounded weekly. How long must that money stay in the account so that you have $1 million? Okay, so this is a situation where we now want to revisit compound interest. This is the only time in which we're looking at exponential growth and decay that we won't be using the exponential growth and decay models. So if we take a look at what we have for this function, we had a of t, this was p times 1 plus r over n raised to the nt. So if we think about what we're given, the amount after some number of years is going to be $1 million. Our initial investment is $5,000. We have our interest rate of 0.076, and we divide this by the number of times the interest is compounded per year. So weekly means that n is equal to 52 because there's 52 weeks in the year. So we raise this to the 52, but this is now multiplied by t. I don't know what time is, so I'm going to solve for time. So how we do this is we need to get the exponential by itself, so I first divide by 5,000. So if we think about dividing this by 5,000, I cancel a whole bunch of zeros there. And so what this ends up becoming is 200 is equal to 1 plus 0.076 raised to the 52, or divided by 52, raised to the 52 times t. Now that I have the exponential part over on the right by itself, I take natural log of both sides. So natural log of 200 is equal to natural log of 1 plus 0.076 divided by 52 raised to the 52 times t. Now the whole thing on the inside is raised to an exponent, so I can move that out front. So I have natural log of 200 is equal to 52 times t times natural log of 1 plus 0.076 raised to the divided by 52. Now to solve for t, t is just being multiplied by this constant and this constant. So to get t by itself, we're going to divide by 52, and I'm going to divide by natural log of 1 plus 0.076 divided by 52. So that goes on this side over here. Both of them will be on the denominator. So that means that t is going to be natural log of 200 divided by 52 times natural log of 1 plus 0.076 divided by 52. So what this looks like on the calculator is you want to say enter a natural log of 200. Then you divide, but you want to put this whole denominator into parentheses. So you're going to put the parentheses of 52 times natural log of 1 plus 0.076 divided by 52. Now I close the parentheses for natural log and I close the parentheses for the denominator. Press enter, and so that says that t is equal to 69.77 years. So just a little shy of 70 years, it will take your $5,000 to grow to $1 million. So this is just a slight different twist on compound interest, where instead normally we would solve for a of t, but what happens if we solve for something like the exponent? We need to use logarithms.